Okay. Welcome back, everybody. So today we're just finishing up a couple extra examples in this area and perimeter stuff. We have a Go formative assignment, not a Delta Math assignment. So that's on Google Classroom. All you have to do is click the link. You should be automatically loaded into formative. Mauricio has already done it, so I think you could probably get in without any trouble. But if you have any trouble, that's homework for the weekend. And we're just going to go over a couple examples to help us through it. And so area and perimeter, I gave us this whole thing the other day of a bunch of areas. Well, it doesn't want to let me scroll that way, so of a bunch of areas, and I put circumference in there in case you kind of forgot circumference. These are a bunch of things we've learned before. Trapezoid and circle might be a little like maybe we don't remember those, but you could always come back to this or watch the video, write it down in your notes if you forget. But basically, my trick to these is separating them into things that I know and what I need to find, what I don't have, how I can find what I need. And basically, to help us solve these, we're going to have to find some missing side links or be creative. And a lot of the times we're going to find missing side links, especially with triangles, is using trigonometry, SOHCAHTOA, that we went over, or the Pythagorean theorem. One of the two, or both. Okay, so find the area and perimeter of this figure. So when I'm looking at this, I see a trapezoid, right? So a trapezoid, I know the area of a trapezoid is 1/2 one base plus the other base times the height. And if you didn't know, it's just in our little formulas. And so, and then perimeter, you just add up all the sides. So, maybe I'm going to draw in something I know. Maybe if I do another dotted line here, I know that that's also 8, right? That's the same height. And then I know that this is going to be 4 if I do that, and if I draw it there. And so what am I missing that I need? I don't know, maybe I'm missing X there. I'm going to need this for the perimeter at least, right? And then I'm going to also need this guy right here. Maybe I'll call him Z. Call him whatever you want. Calibrate the board super fast. Come on. Okay. So maybe let's focus on the area first, because I kind of almost already have it. I have the height of 8 here, and I have one of the bases. I just need to find the other base. In order to do that, I'm going to need to find X and Z, what I labeled X and Z. Okay. How can I find X? Someone's got to know. That might be easier for you guys. How can I get this? I'm good with waiting. How do we find the missing sides of a triangle? Of a right triangle specifically. We got two ways. What did you say, Tanya? What's our two options? Jacob has his notes. That's probably pretty smart. The equation thing. There's a lot of equation things. Maybe if I had two sides, but I only have 8. I don't know X or Y. So what's the other one? Two different ways. That was the Pythagorean theorem. What was the other way? That's the start of your hint. Yeah. Okay, I have this angle here, which says 48 degrees. That might be kind of hard to see, but that says 48 degrees. If I want to find X first, and I know 8, and I want X, so I want to involve the 8 and the X. 8 is opposite of that angle, and X is adjacent. And the one that deals with opposite and adjacent is tangent, the T, TOA. So that means the tangent of 48 degrees equals opposite 8 over X. For no one being able to answer that and not having any notebooks out is kind of concerning. I feel like this stuff, you can't photomath it, so you might have to know how to do it or be able to look back on your notes to see how it's done. But also the other day in Kahoot, only like 5 people knew what the Pythagorean theorem was. So we'll see how this goes. Not taking notes or doing anything. Multiply both sides by X. You get X times the tangent of 48 degrees equals 8. Tangent of 48 degrees is just a number. If we have X times a number and we want X by itself, we better divide it by that number. So I'm just going to divide by the tangent of 48 degrees. And that's just something we could throw into our calculator. 8 divided by the tangent of 48 degrees. 7.2. If you are using the TI, I believe you all have a little TI-84 calculator app on your Chromebook. If you're using that one, make sure you go into mode, and then your third one down, it says radian or degree. You want to be in degrees. Yours will always change it. Okay, so we know x is 7.2, so I'm going to write 7.2 here. All right, so now I almost have the rest of this base. Now I need z. How can I find z? Jacob, now it's you. How can I find z? What did you say the first time? Yeah, right, here's another triangle I made. I had to draw this line down, but I know that this is 8, this is 9. I have two sides of a right triangle. So now, to find z, I can do the Pythagorean theorem. Except one of our sides is z, right? So maybe I'll put z squared. Right, so then z squared plus 8 squared is the other leg equals the hypotenuse squared, 9 squared. Subtract the 8 squared over. Take the square root of both sides. We don't have to put a plus or minus because we can't have a negative side length. And again, something you can just throw into your calculator. We're going to get 4.1 rounding. Okay. So z is 4.1. Now we have everything we need to find the area. Right? So the area is going to be 1/2 times the base 1. So base 1 is just going to be one of these two side lengths. This one is going to be 7.2 plus 4 plus 4.1. 7.2 plus 4 plus 4.1. It's going to be 15.3 plus the second base, or the one up top, so plus 4. And then multiply that all by the height, h, 8. And throwing that into our calculator, I get 77.2. And since it's an area, we could say units squared. Okay, that was the area. What about the perimeter? The perimeter, really the only one we're missing now is y. How can I find y? How do I find y? I just went over the two ways to find side lengths. How do I find this length? Should I bring a chair up here? Yeah. How am I going to find y? This? To find this? We might want to focus in on what about it? You're thinking Pythagorean theorem? Pythagorean theorem works because you have two sides. I'd probably want to do trig because isn't 7.2 rounded? So if I use that, I'm going to get more error. You can maybe, especially if you didn't round it to the nearest tenth. But I'm probably just going to do trig. That way I can be more accurate in the end. Okay, so I have y. This was the triangle I had. This was 8. This was 7.2. This was y, and this was 48 degrees. I want to involve y in the non-rounded number 8. 8 is opposite because it's across from the 48 degrees. Y is hypotenuse. Which one deals with opposite and hypotenuse? Sine. So that means that the sine of 48 degrees, the angle, equals opposite, which is 8, over hypotenuse, which is y. Multiply the y over. And then again, sine of 48 is just a number, so divide by sine of 48 degrees. And just punch it into a calculator. $10.8. So if I go up here, and I just said y is 10.8. Now I have to find the perimeter. All I got to do is add all the way around, right? So 10.8 plus 4 plus 9 plus 4.1 plus 4 plus 7.2. And that'll get me all the way around the circle. And so then the perimeter is 39.1 units. We can try and get through this second one. I don't know how much time we're going to have because we're not answering anything. But we can try. What two shapes do we see? Circle and a rectangle, but not a circle. Almost a circle. Half a circle, a semicircle, right? And so maybe if I see a semicircle and a rectangle, I'm like, hey, let's make it a semicircle and a rectangle. What is this side? 5, right? We can fill in what we know. If that's 5, this has to be 5. What is this? We know this length. Whoever said 3 is maybe on the right track. You say 3. The radius is 3. Is this a radius or a diameter? Isn't the diameter just twice the size of the radius? right? The radius is halfway, the diameter is the whole thing. So it's not going to be 3, but it's going to be 6, right? Twice that radius. If that's 6, and this is 10, what does this little thing have to be? The whole thing has to be 10. So what's this? 4. All right. 6, 4, 10. Okay. Well, the area is going to be the area of the rectangle, right, plus the semicircle. Area of the rectangle is not bad. It's going to be 10 times 5. That's fair enough, right? So now what's the area of the semicircle? Well, the area of a circle is pi r squared. But since we only have half the circle, don't we want to divide that by 2? Right? This would just be the area of the whole circle, but we have half a circle. So divide it by 2. Oh, and we know what the radius is. Pi times the radius, which is 3 squared all over 2. Punch it in your calculator. You have a pi button, or you could use 3.14. So pi times 3 squared is 9 divided by 2. Okay? So the total area of the whole thing, all right, if the area of the semicircle is 14.1, then that's 50. Add them together, 50 plus 14.1. And then the perimeter is not that bad either. All right? We need to find this circumference here. We have all the other things. So we just need to find that circumference. The circumference is pi times diameter, or 2 pi r. But we only have half of the circumference, so again, divided by 2. We know the diameter all the way across is 6. 9.4. So if this is 9.4, this arc around, the circumference is just going to be all of those sides added up. So 9.4 plus 5 plus 10 plus 5 plus 4. You should get the perimeter is 33.4. Go formative is homework. I don't work on it. This is worrying me. See you guys all Monday. Have a good weekend.